This is a lecture on Haskell Types for Comp 360 programming languages at North Carolina A&T State University. Remember that there's a Haskell programming assignment due Thursday night, April 2nd. Please upload the 8 programs as one file with the type extension .hs by midnight. When you put Haskell programs in a file, you can add comments. Comments in Haskell start with 2 dashes and run to the end of the line. Make sure you put comments in the Haskell files that you submit for your assignments. Make sure you have to put your name in the beginning, and then before each function, give a brief description of what it's doing. Haskell is a strongly typed language. All the variables, all the functions have a specific data type. You may have noticed that you don't have to declare Haskell parameter types. Haskell figures out what data types it's using. Although you can specify to Haskell which data types you wish to be using, that makes your intentions much clearer to the compiler. Haskell has the usual data types such as int for integers, double for floating point numbers, boolean, and char. It also has integer, which is like ints, but they can get to be very large. Notice that all the data type names begin with a capital letter and the rest of it is lowercase. You can also make data types. Lists and tuples define data types. A square bracket indicates a list. So square bracket char square bracket is a list of characters. Of course, we always consider a list of characters to be a string. Tuples also define a type depending on the type of the values in a tuple, and of course they would have to be the same if you're using them together. To specify the type of a function parameter and the type of the return, you start by putting the function name followed by 2 colons, and then the data type of the first parameter, and then the arrow going to the right, the dash greater than sign, the second parameter, if there is one, another dash greater than sign, and then the return data type. Here are some examples. If you have a function cow that takes an integer and returns an int, then it's just cow, colon, int, arrow, int. If the function takes a list of integers, then we'll put the parameter type inside square brackets, so it's square brackets int, arrow, int. And if the function takes 2 parameters, say a list of integers and a list of characters, it returns a single integer, then it would be square bracket int, arrow, square bracket char, arrow, int. Try writing this method that multiplies the values in 2 lists of integers. So it'll take a list of integers, a second list of integers, and return a single list of integers. Try this while you pause the video. Here's a possible solution to the problem. Again, it takes an array of or a list of integers and another list of integers and returns an integers. So I have it if null dog, meaning if the list is empty, then return 0. Else, take the head of the first list and the head of the second list. Remember, head gives you the first element. Multiply them together and add them to a recursive call to the method taking the tail of both of them. Tail being everything in the list except the head of the list. When you're using the interactive GHCI system, you can't easily enter the function data types and the function definition. It's possible to do so. You can go colon, curly brackets, end it, but it's probably easier if you put your functions into a text file, load them into GHCI, and then it will compile them and you can use them there. That seems to be much easier than other methods. You mean Haskell doesn't work? There are several ways to enter multiple lines in the interactive version, but since this isn't really interactive, it's easiest to put your functions in a file. Haskell is really good at figuring out the data types you intend for your program. We've been writing Haskell functions without specifying the data types, and yet it figures out what data types we're using. If your function is going to do arithmetic with a parameter, it realizes that that parameter must be a number. If you are moving through it sequentially, then it figures it must be something that has a sequential ordering. In addition to specific data types, you can provide a generic data type. Typically, we use the letter A as a generic data type. So here in this example, we say the tail method, it takes a list of something and returns a list of the same data type. It doesn't specify whether that's a list of numbers, a list of characters, a list of doubles. It just takes a list and returns another list of the same data type. This is an example of polymorphism in Haskell, where the same function can take methods with different types of parameters. Try writing a simple Haskell function and specifying the parameter types and return type that will reverse a string without using the reverse function. Pause the video until you do this. Here's a possible solution. Again, we don't care what the data type is. Reverse takes a list of something and returns another list of something. In my solution, and of course there are multiple solutions, like almost everything that's recursive, the first step is the base case, is the length of the input 1. That is, if there's only one element left in the input, well, then you don't have to reverse it. It's the same forward as backwards. So you just return that value. If, though, it's not the element, then you take the last element using the last function and concatenate that with the recursive call to my reverse with the init, or everything but the last. This works for different data types. You can call it with characters, or you can call it with a list of numbers. In addition to specific data types, there are type class groups, which are groups of data types. All the types in a type class group are similar in some manner. And so instead of specifying a primitive data type like an int or a double, you can specify a number. Here's some of the Haskell type classes. EQ is used for data types that support testing. You can test that one value is equal to another. And most things work that way. For instance, letters, numbers, doubles, you can test to see if they're equal. You couldn't take two functions and say they're equal. Orders are things that have an ordering. Letters and numbers can be sorted in an order. Not everything has an ordering. Show and read talk about what can be presented as a string or input as a string. Num, as you might expect, are numbers. That would be double or ints or integral, all different number types. If you specify it's a number, then it can be any one of the number types. Integral are the whole numbers. That would be ints and integers. So if you want to specify a data class, type class, then you specify the method name, double colon, the type class, usually A, and then equals arrow, and in this case, a list of A going to an A. And that says that we have a method here, sum the squares, that will take a list of numbers and return a number. And those numbers can be integers, integrals, ints, doubles, any one of those numerical types will work here. And I think we've done this method before where it sums the square of all the values. try these. These are some methods that we've been using. Try just writing the data type. Don't bother writing the methods. Just write the type specification for these. Pause the video until you got it done. Here we go. Trim, which removes the leading spaces from a string, takes a list of characters and returns a list of characters. Now, count takes a list of things with which you can test equality, returns another value. It takes a list, takes one to see if how many of these elements are in there, and then returns a number. So you notice there are two different type classes here. One is the inputs of the array and the data value, and the other one is the solution. It's going to be the solution value. So you have two different separated by commas. In the interactive Haskell, you can go :t and give it a function name, and it will give you the type specification of that. So in the first example, we just :t and give it a character string, and it tells us that that is an array of characters. Or you can go :t and give it a function, and it will tell you that. This is pretty helpful, by the way. If you write a function first, and then you go, okay, I want to specify the typecast for it, you can go :t and see what Haskell thinks the data types are, and then you can perhaps be more specific than what Haskell figured out. Here's more Haskell practice. Try writing a function that takes a list of lists and sums all the elements in the list, sums all the elements in each list, and then sums the elements in the list of lists. And of course, it takes numbers. They can be any type of number, whether they are integers, integrals, or doubles, and then takes a list of lists and returns that a data type of that type. So pause the video where you try that. Here's a possible solution. So again, we're using numbers, any type of number. And so if the list is null, meaning if the list is empty, then the answer is 0. Otherwise, take the sum of the head being the beginning of that list, which is a dog, then would be a head of dog is a list in itself. So in this case, head of dog is the 4, 5, 6 list. And then we cursively call it to the sum list, which is the rest of the list. And we can try it with different data types. Here I passed it integers and it returned 10. Here I passed it some doubles and it returned a double solution. Notice it's a double solution even though it was an even number. It's the sum. Don't forget, by midnight on Thursday, April 2nd, you have to submit the 8 simple Haskell functions. If you have any difficulties writing them, please contact the instructor, Ken Williams, and we can do it by email or we can Zoom if you like. Keep working on Haskell. There's more to come. Read Chapter 4 of LearnYourHaskell.com.